Okay, good morning. I think we're ready to start. Ward, are you ready?
I am ready.
Great. Well, welcome to this webinar. I'm Laura Beth Allen with TAPPI. This webinar is a sponsored TAPPI webinar, and it is sponsored by Valmet, and we'll be covering tissue technology. Before we can get into the bulk of the content, I need to cover just a few housekeeping rules. Like this webinar will be held in strict compliance with TAPPI's antitrust policy. If you have any additional questions about our antitrust policy, you can find some answers at tappi.org. You are muted as an attendee today. If you would like to submit a question to our panelists, you can open up Zoom's chat feature. It should be located at the bottom or top ribbons of your screen, and it will say chat. You may have to click the more button to find the chat option. And once you submit your question, the panelists will be gathering those to follow up at the end of the presentation. There will be a 10-minute Q&A session after the last presentation. We encourage you to ask our experts any question. If we run out of time during the Q&A, you'll be followed up with, and we'll be saving all the chat. After the presentation, you'll also be given a SurveyMonkey survey link. It's really important for us to get your feedback, and we'll also be providing some ancillary documents from Valmet on the survey. If you need the contact information for any of the speakers, it will be located there as well. If you have any technical difficulties, you can contact me at TAPPI. My email is lallen@tappi.org. At this time, I'd like to introduce Ward Patton. He'll be the moderator for today's webinar.
Welcome to the Valmet Tissue Technology webinar. We're so happy that so many of you could attend this morning, this afternoon, this evening, wherever it is where you are, as our experts tell you about how our new technology can help you move forward in reliability and performance. We'll be hearing 4 speakers today. David Epen will start telling us about how leveraging big data analytics on tissue machines, how to go about doing that. He's a sales manager for industrial internet applications. Johan Rogard is concept manager for textured tissue, and he'll be discussing flexible tissue making, specifically the hybrid advantage. Heikki Luoma, capital sales manager for tissue machines, will talk to us about sustainable rebuild opportunities. And batting cleanup is Andrea Coluccini, who is a sales manager for tissue rewinder technology. And he'll tell us how to focus on no-stress tissue winding. Be talking about rewinders. And we will start with David Epen. David, if you would take it from here.
Yeah, thank you. Thank you, Ward. And thank you, everybody, for joining. So as Ward said, I'm going to be talking about Valmet's industrial internet solutions, and specifically how we are leveraging big data analytics to improve performance on tissue machines. So before I get started, I'm going to spend about 1 slide giving everybody on the call here a quick definition on what we mean when we talk about industrial internet. It is, it's a buzzword that's thrown around a lot, so I want to give you what it means from Valmet's perspective. So to start off with, when you're going to hear us use the phrase a dialogue with data quite a bit, essentially in very simple terms, when we talk about industrial internet, we are talking about converting data into actionable information. Typically, at most of your mills, you guys are generating a significant amount of data every day, every month, every year. On average, less than 3% of that data ever gets looked at. And that's usually for KPI reporting or to troubleshoot the process. The remaining 97% of the data is just archived. So what we are trying to do is to look at all of that data, deploy our process expertise, machine learning algorithms to look for patterns, to look for insights in the data, with the goal being to reduce costs, reduce downtime, and also improve product quality. So to reiterate in a nutshell, I'm going to be talking back to this quite a bit, but just because I think it's really important and it gets the message going for the whole presentation. The goal is we want to convert data into actionable information. That's the theme of what we are trying to do. Ward, could you move to the next slide, please? So here I talk about the key elements of our industrial internet offering. At the core is the Valmet Performance Center. And what this really is, I'm not sure how many of y'all have heard of this term or seen the marketing material from us on the Performance Center. But really what it is it is a remote expert center where we provide remote support, remote monitoring, data analysis, and also it acts as a bridge between our Valmet customer experts, our Valmet process experts and our customer experts. And of course, as I mentioned, the theme of my presentation is converting data into actionable information. So a key part of that is to give data context. So the next piece of our industrial internet offering is exactly that, is the set of applications and suites that we have built to give that data context. And today, during the presentation, I'm going to focus on 3 specific applications. But the goal is to, as I mentioned earlier, we are using machine learning algorithms, which is a subset of AI, to build models to predict certain outcomes. So I'll talk about that a little later on. And as I mentioned earlier, 3 specific cases. Another key component to the right is the Valmet Customer Portal. And this is really a digital collaboration space between our customers and the Valmet experts. So a lot of our applications, a lot of our analytics, depending on the specific customer case, we may run them in the cloud. We use Amazon's web services. So essentially, any customer that has access to a web-enabled device has access to those applications and services through the Valmet Customer Portal. So that's really the collaboration space. I'm not going to talk about that much today. As I said, I'm instead going to focus on the applications. But all of these components are underpinned by good intelligent automation. So we need to make sure we have the right instrumentation and also a reliable data source. So that is also another key component. And the last piece, which I won't talk much about, is the solution ecosystem. So this is really an effort that Valmet has been making to bring together, to co-create with our customers, but also with other industry players, especially in areas where there's added value of working together. So that's really, in a nutshell, key elements. Ward, could you move to the next slide, please? All right, so this slide, before we get into the applications, this slide provides a very high-level view of some of the services and applications that we currently have for tissue producers. Again, I had to keep it a little condensed for this presentation, but broadly speaking, it can be classified into 3 categories. To the left is the advanced reporting and guidance. In the middle is the asset reliability piece. So this is a set of applications and services that are specifically focused towards asset health and asset reliability optimization. And finally, to the right is the set of applications and services that are focused on operations performance optimization. But all of these are underpinned by the Valmet Performance Center. So as I mentioned earlier, the key here is we need to make sure we have a reliable data source connectivity. Through the Performance Center, we can provide on-demand expert support, the remote monitoring, and also the analytics. Next slide, please. So here, for the presentation today, I'm going to focus on 3 specific applications for tissue producers. These are the ones that I've highlighted in blue, and I'm going to be focused on the performance optimization piece. So we'll talk about the real-time quality predictor application. We'll talk about a break predictor, which is the runtime prediction application, and finally the centerline tool as well. So hopefully this is going to be interesting for you all, and everybody gets a little bit from this. Next slide, please. All right, so the first application I'm going to talk about is the real-time quality prediction. The main focus here is So the main focus here is to be able to provide customers and specifically operators with a real-time view as to what the quality parameters are doing. In most cases, quality samples are taken once every hour or on the reel or once every couple of hours. So operators can have to run blind. Our goal here is to deploy tools that exist, modeling tools that exist today, to be able to provide a real-time prediction on what the quality is. So for example, on a machine, we would take all of the data from the stock prep to the reel, which is a couple of thousand tags, could be even more. And we deploy machine learning algorithms to build a model using that data. And specifically, the outcome of the model is focused on certain quality parameters that we define together with the customer. So the example that I have on this slide here is on a liner board machine, but we've also done quality prediction on tissue for, in the examples I can talk about are CDMD, tensile, stretch, caliper, and also bulk. But in this example here, what you're looking at is the blue line is the measurement, and the red line on the top right corner trend is the model. So you can see that the model tracks the lab measurements pretty well. We use a metric. We use the R square, to tell us how well we are correlating. And in this case, it's about 85% for about 6 months worth of data. Typically, for this kind of data analytics, an R square of over 60% is considered good. Just to give you some context, if we are building models to predict human behavior, an R square between 3 and 5% would be considered good as a starting point. So that's how it can vary depending on the specific application of the tool. Could you next slide, please? So this is another example. This is on a tissue machine. The red dots represent the lab samples, and the blue represents the modeled value. So naturally, with just the discrete samples taken, there's quite a lot of variability. But with the real-time prediction, the goal is for the operators to run closer to the bottom end of the spec, so which is represented by the green line on the trend, which directly translates into savings for the customer. So so this is just one example of how we are leveraging data analytics to predict quality in real time. And again, for most of these cases, the existing instrumentation, depending on the age of the machine, would be good enough it's all about, like I mentioned earlier, converting the data that you already have, already archived, converting that data into actionable information. So on the next slide. So on this slide, here I'm going to talk about the next application. This is a web break prediction application. The name is pretty descriptive. The goal here is to be able to predict a break early enough that the operators can then take corrective action. And we define early enough as at least about 45 minutes in advance of when a break occurs. So again, the here is to take years worth of data, deploy our algorithms to train on, let's say, 1/2 of the data to build a model, and then to test the models on real-time data. Typically, for this kind of an application, we are looking at a prediction accuracy. Again, depends on the specific machine, but we are looking at a prediction accuracy varying between 20% and 45%. So, significant potential if the operators are able to reduce breaks by even 20% or even going as high as 45%, that can be significant savings. So on the next slide is an overview of what the application looks like. This is a demo version of a real application. What you see on the trend here is the prediction scale from 0 to 100%. So 100% being that the application is predicting 100% probability of a break, and 0% being a 0% probability of a break. The trend changes color from green to orange to red, depending on how high the probability of a break is. So it's a visual representation of driving the operators towards taking action. The vertical gray bars you see are the actual breaks. So you can see, there's towards the left, there are a couple of breaks that we didn't catch, or at least the application was predicting only a 30% chance of a break, and they did have a break. But again, these are machine learning algorithms. There's also random events to consider, but the algorithms and the application also get better over time. So you can see towards the right-hand side, there is a little bit better accuracy and early warning in terms of being able to predict a forthcoming break. To the left, you can see the top 3 measurements that are driving that probability change. So again, this is additional insights for the operators that, when we see the probability change, the application will list out to the operators, what are the top variables that are driving that change. And hopefully that gives the operator some insights into what corrective action they would need to take. So again, the focus is, using your existing data, but just converting that data into actionable information to, in this particular example, minimize breaks. And the next slide, please. So over here, this is an example of the centerline tool. And again, here, just to give a little bit of context, the challenge for customers, especially in North America and Western Europe, is that there's a lot of flux between, you have your experienced operators retiring, and how do you retain that knowledge and build tools that enable the less experienced operators to get up to speed quicker. So that's really where this particular tool is born from. We are basically building a guide for operators to use in terms of where the best, where the best potential places to run are depending on the particular target parameters. This is a summary of some of the activity in the industrial internet space from Valmet's perspective. This is a quick overview. So we have 8 of these Valmet performance centers where we support our customers remotely with expert support with analytics from around the world. 5 are focused specifically on our customer segments. So that is pulp, paper, energy, tissue, and automation. And 3 are regional performance centers, one in North America, South America, and also China. And we have a couple more in the pipeline for Asia Pacific and so on. I work from the Atlanta Performance Center, and that's where I'm giving this presentation from. We have about 350 advanced process control installations, about 540 online connections with our customers, and 90 with performance agreements where we provide some additional value, insights, and performance improvement. And then the 46 number is an example of some of the activities in our performance center. So 46 tickets we've closed with 13 different with customers from 13 different countries, specifically just on board and paper. And again, of course, we're constantly working with our customers to co-create applications and also, drive more data-driven analytics in terms of performance improvement. So that's really what I had. Thank you again for attending. And if you have any questions, put it in the chat window, and we can follow up later on. Thank you.
Thank you, David. And now we'll hear from Johan about hybrid technologies. Johan?
Yes, hello, and most welcome everyone to this webinar. So today I will talk about 3 new technologies here. It has actually been on the market for a while. For example, the first entity machine started up 2013. So next slide is talking about the market needs, and there is always an increased demand of improved quality there, and it will continue all the time there. But then this hybrid, those new concepts, they combine the new product quality with very good energy consumption and also fiber usage. But it's not only to produce the paper to a low cost. It is actually how to use the fiber and the energy as low as possible there for a sustainable and environmental. So actually, next slide then is today we will talk about these three concepts in the center, this hybrid, and we developed these three different concepts based of the needs of quality. We also have a swing capability, energy consumption, and then also production and efficiency. So I will walk you through these three hybrids, the entity, QRT, and eTAD there. So the next slide, the entity there, if you look at that configuration there, if you compare that to conventional machine, then you are adding another fabric, just the entity belt. And what it's zoomed in here in this rectangle is the heart of the entity. And it's the entity belt together with this pre-press that we call the cymbal press. And that is a high loading element there, 2 to 3 times higher than the conventional, and 2 to 3 times higher than conventional pressing there. So that's why we are achieving extremely high dryness numbers and this good energy efficiency. But in this pre-press there, we are transferring and creating this structure of the paper. So this 3-dimensional shape will be created there in this pre-press there. So next slide there, and you can do another push there. So next, yeah. And here it's actually showing then the principles there, and that you are transferring it from a felt over to this entity belt there, and talk a little bit more about the entity belt. And since we are creating the texturing of the belt by a laser engraving, there is endless possibilities of different type of pattern. So I would enhance this type of pattern that is available there. More or less everything is possible to make different logos and patterns. Yes, next, that was only the entity there. So next slide is really talking about the QRT. And if you have the entity in mind, what is the difference with the QRT then? It is that the QRT are adding another type of clothing or fabric. It's adding a structured fabric after this entity belt section there, and adding this rush transfer principle there. So that's really the upgrade and additional to this entity type of machine if you compare it to that. So next slide is more showing the principles here, that you are coming from the wet end. It is really a crescent former type of wet end. You are making a pre-dewatering first with a vacuum suction roll, entering into this pre-press, cymbal press, where you increase the dryness to a very high dryness levels, to this transfer belt that is really the entity belt. But then the difference is this rush transfer nip that we are moving over to rush transfer, and in the QRT we are using a suction crepe roll, and then we enhance it a little bit further with the molding box. So probably next slide then is showing more the principle there. I'm not sure how easy it is to see, but anyway, the rush transfer principle is that it will slow down the speed or the velocity of the sheet. So you are rushing it into this structured fabric to generate higher bulk. That's really the QRT. And then, so next slide is then showing the eTAD. And what is really this, there is a few similarities to the QRT. It has the same number of fabrics. It also has a rush transfer. But next slide is perhaps showing then what is the difference to the QRT then. You are coming into this pre-press, very similar to the QRT here, but instead we have a visconip pressing against a backing roll that is heated. And if you compare it to the QRT, if you remember that had a transfer belt instead of this backing roll. We are spraying some release and have a doctor against the backing roll. But the difference is also we are only having a crepe roll without vacuum. So that's the biggest difference between the QRT and eTAD. So next slide is also showing then the principle here, how it's rotating there. So then talk about next slide about the properties here. Why, perhaps the question is why we have different concepts that seems to be very close to each other. But this slide is showing differences between at least the QRT and eTAD, that you can do different rush transfers with the QRT versus eTAD. So the QRT are running from 0 to 10%, and the eTAD are running in the higher range of rush transfer. So you can generate more bulk with the eTAD, but on the other hand, you will be more difficult to run the low rush transfers. And the summary is then trying then to understand what is the market demand on the product quality you need, how much fibers and energy usage are you willing to make, and then also we haven't talked very much about the swing capability between conventional type of machines versus this structure. So it's a balance between those 3-4 aspects that you need to have in consideration when choosing these technologies here. So thank you very much. And so the next slide there is actually able to be prepared for the future, and the future might surprise you there. Thank you very much.
Thank you, Johan. We'll hear from Heikki now about sustainable rebuilds. Heikki?
Okay, thank you, Ward, and hello, everyone. My topic today is really a brief look into some sustainable rebuild opportunities for tissue makers. And we'll focus mostly on ways to reduce energy use and the resulting operating costs. Let's go to the next slide, Ward. So you can see that there's a number of rebuild products and technologies that Valmet can offer to tissue makers. And today we're going to focus on 3 that have demonstrated in significant energy savings, and thus they enhance the sustainability of a tissue machine. We'll look at return and ReDry a little bit later, but first let's look at ViscoNip, which is Valmet's latest extended nip press technology. Next slide, please. So let's dive right into the heart of the tissue machine, and let's look at the ViscoNip in section. So what you can see is that the loading element differs from other extended nip presses in that it is flexible. It's made of polyurethane, and the 2 hydraulic chambers are how you develop the press load. As the pressure is increased, the loading elements deflects, and this provides the resulting load on the Yankee cylinder. And this load can be easily changed both in overall magnitude, but also in relation to the relative pressure in each chamber. This pressure ratio is called the tilt ratio, and it determines the shape of the resulting nip pressure curve. This capability allows the tissue maker to operate the press in a variety of different ways that improve overall dewatering and can enhance product quality, all from a few DCS changes that happen in a matter of minutes. Next slide, please. So when you design a press to nip against a Yankee dryer, it's important to have a good understanding of how the Yankee dryer deforms. It's relatively stiff to bending, and most of the deformation is actually caused by shell deflection. The deformation is significant at the center of the Yankee, but much less so at the edges due to the relative stiffness provided by the heads. The resulting deflected surface shape is complex, and it can be difficult to match with a roll press or a traditional shoe press with rigid loading elements. The ViscoNip press has been developed to maintain a uniform press load even though the deformation of the Yankee shell is complex. This is done by having a flexible polyurethane loading element that adapts very well to the deflection of the Yankee shell. Next slide. Let's look more closely at the specific issue and how the ViscoNip solves it. So if you look at the Yankee and ViscoNip in section in this animation, you can see how the flexible loading element can effectively and evenly conform to the deflection of the Yankee, both at the center as well as at the relatively stiff edges. This results in a very even loading across the machine at any operating condition of the press and Yankee system. No longer do detailed and specific crown calculations determine how you operate the tissue machine. ViscoNip gives you the ability to operate the press in an almost infinite number of ways. Next slide. So you can operate the press at a low linear load and change the relative pressure in the chambers to give these three nip pressure curves. And this loading strategy would be useful to preserve bulk in the final product due to the relatively low peak nip pressure. Next slide. Or you can increase the overall load and still operate the press at different tilt ratios. This loading strategy would be useful in generating the highest press solids and thereby reducing overall drying load. And let's not forget that these changes are achievable in a matter of minutes with only a set point change in the control system. Next slide. So that said, ViscoNip offers a number of benefits over roll presses and traditional shoe presses. The first of these is energy savings. So next slide. Press solids content of up to 47% has been demonstrated in a number of references, both with virgin fiber and with recycled fibers. And since a 1% increase in press solids typically reduces drying load by 4%, this can significantly reduce overall energy consumption of the tissue machine. Next slide. The second key benefit of ViscoNip pressing relates to the uniformity that is achievable with this technology. And next slide. By being able to adapt very well and press evenly across the machine, even at the edges, ViscoNip gives a very even moisture profile. That means that the sheet is evenly transferred to the Yankee, it's evenly dried, and then evenly creped. This results in a better sheet at the reel and then onwards into converting operations. In some rebuilds, this has allowed the tissue maker to remove the steam profiling shower and its associated steam use. The CD profile no longer needs to be corrected with a profiling device. Next slide. And then the final benefit that relates to the flexibility that the tissue maker now has in how they run their machine. As I mentioned earlier, crown calculations are not needed due to the flexible loading element, so no longer does a specific set of conditions dictate the press operation. The tissue maker is free to operate the press and machine in a number of different ways depending on what end result they're looking for. For maximum energy efficiency, you would seek the highest nip load and specific nip pressure. And to retain bulk, the press load would be relaxed and the tilt ratio would be lowered. So depending on the production needs, the pressing conditions can be changed quickly to produce the desired effect. This ability to easily and quickly change the machine means that the production line can be more responsive to market demands and thus makes it more valuable within the organization either as a single machine or as a way to provide overall manufacturing flexibility within a corporation's fleet of machines. And being efficient, flexible, adaptable to change, well, these are all pillars of overall manufacturing sustainability. So let's look at another technology that also helps in this regard. Next slide, please. This technology is called ReDry. So if we go to the next slide, and we look again at the press section of the tissue machine, there's always been a need to improve dewatering at the press specifically. The previous technology we looked at also had this as one focus area, and ReDry does as well. Anytime you can raise the temperature of the sheet at the press, you dewater more effectively due to the reduced viscosity of the water in the web. That effect is commonly achieved today with a steam shower. But in order to do that, a steam box does consume steam and contributes to the manufacturing cost as a result. ReDry can give the same effect, but with less cost because the heating source is not live steam, but rather the Yankee hood exhaust air. So in practice, you can get the same or better benefit without the operating cost. Next slide. From a practical perspective, this rebuild is fairly straightforward. Can you advance the slide, please, Ward? Thank you. The ReDry component is installed in the press section, either on the suction pressure roll or on the vacuum dewatering roll of a visco-nip machine. The air system is installed on the mezzanine and it draws the Yankee hood exhaust into a fan that supplies it to the blow box on the machine. Temperature is controlled by bleeding in relatively cool mezzanine air, and the overall flow to the blow box is kept lower than the exhaust flow from the roll. This is done to ensure that the blow box does not blow hot air into the machine room at the press. In a rebuild, the majority of the installation work can be done without stopping the machine, but installation of the blow box and the final duct connections would be done during a short outage. Next slide. In this reference case, we can see the effect of a visco-nip rebuild as well as the additional benefit that is realized with ReDry. The visco-nip press alone improved press dryness by 4.5 to 5.5% compared to the suction pressure roll that it replaced. When the ReDry system was turned on, the press solids increased by another 1.5%, so that the combined effect was a 7% improvement in press solids. This is truly a dramatic reduction in drying at load that can be used to either save energy or increase production if the machine is drying limited. Next slide. One other aspect of this improvement should also be mentioned. Because ReDry saves energy and due to visco-nip's operational flexibility, this combination allows the tissue maker to further reduce press load and build more bulk. This effect can then be translated into higher quality tissue at the reel. So the combined effect of a visco-nip and ReDry rebuild truly is a winning combination in many ways. Okay, let's go to the next slide. Our final rebuild opportunity shifts from the press section to the wet end of the tissue machine. Return is an energy savings tool that captures the headbox jet's kinetic energy and turns that into electricity for the tissue machine drives. It was developed when the simple idea about how to handle water in the wet end sparked us to ask the question, why is this energy wasted instead of used? And really the idea and the solution are quite simple. Next slide. There are three main elements to return. The guide plate directs the water that is passed through the forming wire. The turbine is used to transform the kinetic energy of the water into rotational energy, and the generator changes this rotation into electrical energy. Next slide, please. When the system operates in recovery mode, the water from the jet is directed by the guide plate to the inlet of the turbine. After the energy is recovered, the water is released from the turbine into the save-all and then is directed to the flume. Next slide. If there's a need to stop the turbine for maintenance, a mechanism is used to move the guide plate closer to the forming roll, and this directs the water past the turbine. This ensures that the tissue machine can continue to run without interruption in either recovery or bypass modes. Next slide. The generated electricity is directed to the drives of the tissue machine, and this dramatically reduces the resulting demand on the electrical grid. In the references that are installed and running, it is quite common to capture 50% of the headbox kinetic energy, and depending on the operating conditions of the machine, the resulting savings in electricity can be as high as several hundred horsepower. And the next slide, please. So return clearly is a rebuild opportunity for all Valmet DCT machines as well as other machines. And the best way to look further into this sustainable rebuild opportunity, as well as the other technologies that we reviewed today, is to contact Valmet and review the specific details of the machine in question. So thank you for your time and attention, and I'll hand over the discussion to our last presenter, Andrea.
Oops. Andrea will tell us about tissue rewinder focus, our state-of-the-art tissue rewinder. Andrea?
Yeah, thank you, Ward. Hello to everybody, and thanks one more time to be here with us. Today I'm going to introduce our rewinder technology. Next slide, please. The model reel is the first stage of a quite long converting journey before the tissue paper produced by tissue machine becomes a finished product available in the consumer and away from home market. as a toilet roll, kitchen towel, napkin, handkerchief, etc. The tissue model reel produced have a certain characteristic, specific tensiles, creep, bulk, softness, which are essential for the final tissue product. Next slide, please. Let's analyze a bit which are the forces involved during the winding process. First, the winding reel with its own weight, absolutely. Second, the chuck's relieving action. Rider roll, linear load. The nip on drums is the resultant of these forces. Next slide, please. With the conventional technology, the rider roll, linear load, and chuck's relieving action are actuated by a hydraulic cylinder, according with the pre-established curves, based on practical operation experience, and in this condition, there is no control of the bulk. Next slide, please. During the rewinder process, the bulk is the most important parameter to save in order to preserve as much possible the original characteristic of the motor reel. Currently, Valmet is the only rewinder available in the market that can prove a bulk loss below the 3%. So let's introduce our focus concept. Next slide, please. The heart of this technology is our patented ACC, Active Caliper Control, a closed-loop control with feedback from load cell mounted on rider roll and chucks. The ACC permits an effective control, keeping consistent the nip of the winding reel on the carrying drums during the process at any speed. With Valmet Focus E and ENS model tissue rewinders, the operator simply needs, before starting the production, to set the desired nip value and the web thickness. The rewinder will calculate automatically all the other parameters according to the production plan, and in case of the initial web thickness data set is not correct, the system automatically adjusts the web thickness set point in order to reestablish the control balance. Next slide, please. The process is carefully controlled not only electronically, but also through our electromechanical technology. Chucks relieving and rider roll pressure are actuated by a precision ball circulation screw. Advantages are clearly described in the slides: precision, clean operation, and lower and easier maintenance. Next slide, please. As I mentioned before, our main purpose is maintain the original characteristic of the paper rewinded, as like the original model reel. In the ENS models, the typical focus electromechanical relieving approach has been implemented with a complete automatic system, no stress, that permit to move the finished reels by a very smooth operation through our electro-actuated shuttle. The second benefit of this application is the perfect alignment of finished reel and the shaft puller. The design of this solution permits also an easy access to carrying drums for cleaning and maintenance. Next slide, please. Here you can see a couple of pictures of our Focus Relight ENS installed in line with the tissue machine. Next slide, please. Traditional technology is also available in our production range. The particular design of our line Series T permit with the specific adjunct kits to update the supplied line from basic hydraulic shaftless to hydraulic shafted, and furthermore from hydraulic shafted to our top technology, electromechanical with bulk control. Next slide, please. We apply to our Relight Series T a scalability concept. T means transformable. Next slide, please. Next. From the initial basic supply hydraulic shaftless are available 2 extra steps of modification to improve not only the performance in terms of speed and production capacity, but also in terms of enhanced quality by bulk control with our mechanical technology. Next slide, please. To summarize, our scalability concept, customer by the time and according with the production needs could upgrade the existing line in performance and quality starting from the basic configuration. Next slide. A couple of examples of our focus T-line model. Next slide, please. In conclusion, a brief consideration. Since we start to introduce in the market our electromechanical line with bulk control, the number of electromechanical lines put in operation is by far more than traditional hydraulic type. And in many cases, are repeated orders showing clearly the appreciation of this technology. Next, and thank you very much for your kind attention.
Thank you, Andrea. And now we have a lot of questions that have been coming in. First, David, were there any questions directed to you that you would like to answer now?
Yeah, Ward, can you hear me?
Yes.
Okay, fantastic. So I see a question from Jin Hyun. Thank you for the question. It's quite a detailed question, so I'll try to maybe condense it a little bit and give a general answer to the group. But essentially, the question was around the fact that when we do the quality prediction, and even in some cases, the root cause analysis, there are quite a lot of variables that can have an impact. So how do we know which variables we're looking at, or which variables we should be focusing on? That's an excellent question. It is extremely challenging because you're right. I'll give you an example. One of the cases that we worked on, we had about 6,000 tags, and when we did the first pass at the data discovery, our data scientists found statistical correlations for about 2,000 tags that were affecting the output. So it's almost impossible to provide insights, with that many potential impacts to the operators when it's that large. So, but one of the differentiating factors for Valmet is, we took that list of 2,000 tags that correlated with quality, and we ran that by our process experts, and we were able to narrow down that list from about 2,000 to about 110. So it's that's a big differentiator versus just a software company, because we have the OEM expertise and the process experts. We can filter out the data. Of course, we're not trying to hit 100% correlation. We're trying to find that balance between good enough prediction, but also actionable insights that the operators can then take action on. So it's a bit of a fine balance. And what I will do also, Jim, is to, since you had a couple of questions that centered around specific cases, what I'll do is I'll send you an email with some of the responses that we can get this conversation going.
Any other questions, David?
I'm trying to look through the list over here. There's one generic question about, the data, are these industrial internet applications limited to any specific DCSs, or how the data collection goes? I'll just give a very generic answer. These solutions are DCS independent. Essentially, we collect data from your existing historian, it can be a PI historian, and we push that data to the cloud. And all of the analytics essentially run in the cloud. So in that kind of a deployment where the data is collected in the historian and pushed to the cloud, there's really no hardware involved. In certain cases, when there isn't a historian at site that is collecting all of the information we need, we could also run an edge server which collects information locally, and we could even run the applications on that server locally. So that's a little bit about that, but nothing else that I see here, Ward. If you see something that I missed, please let me know.
Okay, thank you very much, David. Johan, were there some questions that you could handle?
Yeah, thank you very much for all these questions here. So I will pick a few of them there and try to answer them. And the first one today is how much can a visconip improve bulk compared to DCT, LDC? But it's actually perhaps, I will answer it based from a suction press roll machine, and visconip itself without this hybrid that can make it up to between 5 to 10% higher bulk. Entity in plane mode, we will say 10% increase. But then if you switch and swing to a texture mode, then it's more 50 to 80% bulk increase. And then the QRT and eTAD, they are more similar to each other, and that's more like 80 to 100% bulk increase. That's one of the questions there. The other one was what maximum loading of a visconip in entity machine. But first of all, I would say, what is the loading of a visconip just if you have it in conventional mode? Then it is 150 kilonewtons per meter. But if you compare the entity, that has 600 kilonewtons per meter, and if you make a correlation instead of the pressure itself, peak pressures, conventional machine are between 2.5 megapascal, and entity machine is up to 6 megapascal. So that's like 2 to 3 times higher peak pressures. That makes this high dryness value there. Perhaps the last question I will answer today is it possible to run eTAD and QRT as a conventional mode, this flat mode? And in a way, yes, but I would say entity is really comparable to the conventional there if you run that in the plain mode. QRT, you will not be able to run exactly the same, but with a fine fabric, you can run close to conventional. eTAD has more difficulties to run a conventional type of paper because you will end up with more rush transfer and more bulk. So it's really comes into this swing capability. Do you need to produce conventional type of paper, and how much is this premium type of paper, structured type of paper? Okay, that's perhaps 3 questions from today there.
Okay, thank you very much, Johan. Heikki, are there some questions for you?
Yeah, I see there's one here that directly relates, so I'm going to answer. There's a question regarding, is the forming zone extended, or extending, I guess is what was said, when you use a return? And generally, no, the forming zone or the geometry of the headbox or the jet or anything like that is not. All of the equipment that's installed for return happens sort of after you've passed through the wire, so everything happens inside the save all. So really, you don't have to change anything with regard to the headbox geometry or jet or the forming roll. Really, you're looking at things inside the save all.
Any other questions, Heikki?
No, I think Johan covered some of the other ones that I was going to answer, but we're all good.
All right. Andrea, do we have some questions regarding focus rewinding?
Yes, I have one question. Wouldn't the screw drives on the rider roll and core chucks be susceptible to damage from vibration of the winder? How do you dampen vibration? Okay, it's a good question because permit me to compare our electromechanical technology with hydraulic. At least our screw diameter is higher compared to the hydraulic cylinder. So in some way, we start from a more stronger mechanical structure. And in the whole installation that we made during the last years, we never been susceptible in damage for vibration. So we never need to dampen the vibration because we neither have issues of vibration. So thanks to the to the server that make this question to clarify this matter.
Any other questions?
No, absolutely.
Okay. If we miss the questions, we'll make sure to come back, review the question list, and get answers to your questions via email after the webinar. And thank you, presenters, and thank you, TAPPI, for hosting this webinar. And thank you very much, attendees, for taking this time out of your day to learn more about Valmet technology. And that's the end. Thank you.